on Tuesday and ask me questions before it's actually due. So I've started the timer. Yes, have I? Yes. So I have 19 minutes left to get through this lesson. So I believe that we will not have any problem taking care of that because you guys are great. So you and your friend go and mow yards. Anyone mow yards for money? Yeah? Okay. So Noah, let's say Noah and Pranav go out mowing yards for money. Now, at different houses, the people have given their payment to either just Noah or just Pranav. So, might as well label this. We'll say Noah and Pranav. So Noah has 2 envelopes that both have the exact same amount of money in them, and then a 5, a 5, a 1, and a 1. Pranav has 1 envelope with that same amount of money in it, but we don't know how much it is. But this person has told us it's the same as every other envelope. And then Pranav's got a 10, a 10, a 10, and then 6 ones. So, if they want to split this, did you not get the notes? Is that why you're raising your hand? I'm sorry, but I thought you were having a question. I was just going to get through it.
I'm sorry I didn't see you back there.
So, right now, Noah's a little peeved.
Why are you so
Peeved is like annoyed, angry, upset. Noah, why might you be upset right now? Looks like Pranav's got all the money.
But he doesn't.
Well, he's got most of the money.
You don't know?
But he doesn't know of money. That's a value.
But check this out. They split the money they made evenly. So actually, they both have even amounts of money right now. So what we can say is these two are equal. So how would we set this up as an equation to figure out what's actually in those envelopes? Lily?
Would you add the money together and then do 3x plus,
Ooh.
because there's 3.
If we make this the middle of my equation, is there 3x on one side?
No.
I agree there's 3x's total. But if we look at just what Noah has right now, what's Noah got in the envelopes? How many envelopes? 2. Each envelope has?
$500.
Well, we don't know. It's got x, so we're going to say 2x. Plus, Noah also has cash in hand. Nate? 2 5s, 2 1s. 12 bucks. Pranav right now has how many envelopes of X?
1.
Just 1, so just X. And then how much cash in hand? 36 bucks. So now we've got to do some tricky little math to get my constants together and my variables together. So you need to make the choice. There is no wrong choice here. You need to make the choice of which side you want your variables on and which side you want your constants on. I like to have my variables on the left side and my constants on the right side because then eventually I will get an x equals whatever. And I just like when I read it to see the variable first. So how would I get rid of the constant on the left side? Zach? Subtract by 12 on both sides. So that now tells me 2x is equal to x plus 24. How would I group all of my variables together, Karen? Yeah, I don't want my variable on the right side. I want to move it over here, but the way that we move it is to get rid of it here. So exactly what Karen said, subtract x from both sides, and that gives me x is equal to 24. So in each of those envelopes was $24. So Pranav is not trying to rip off Noah. They have the same amount. Each envelope is $24. Because then if we plug that back in, well, each envelope's 24, so really these together are 48. Plus, you guys said he had $12. If we plug it in here, Pranav has one envelope of 24 plus the 36. both of those will come out to equal
60.
60. So each of you guys made $60. That's a good pay for a day. Yeah.
Before I started solving this, I looked at the money and I added 12 plus 12 and I got 24. And that equals on the red one. And then I did 36. So then I did 24 plus 36 and I got 6.
Can I look at your work?
Oh, okay. Well, so,
You don't have work to show me?
well, no, I don't. But can I write it up?
We are in a hurry today because we got to finish the mastery too. So let's chat about that later. Make sure you understand the technique that we just took. Your way, I think, is right. You just kind of use some mental math that doesn't really have a way to show it. So on like a mastery or on like one of those standardized tests like the air test, you're going to want to show out that work. I mean, assuming it asks you to show out the work. So this just goes through what we want to do. When we write an equation that involves constants on both sides and variables on both sides, we just make the choice, where do I put what I want? Well, on the equation here, we've got a negative 3x on the right side, a positive 2x on the left side. We've got a positive 1 on the right side, a positive 6 on the left side. So to get rid of my constants, now they decided I'm going to go constants on the left, variables on the right. And they show two different ways to manipulate that. They get to here, and then we could subtract 1 from both sides to solve. Or they get to here, and we could subtract 6 from both sides, and then divide to solve. So both those are just showing different ways that we can manipulate the equation, different choices we can make. We could either subtract the 2x from both sides or add the 3x to both sides, whichever you decide to do. So in this example, set it up, try to solve it on your own. We have 6x minus 9 equals 4x plus 3. Digits might give me some more space.
That thing you posted on YouTube yesterday.
Oh, the Digital Danger Talk?
Yeah.
Are you subscribed to me? Is that how you know that? Okay. It was from the parent forum last night. We had, and they'll be coming back for 8th grade. It was Dr. Tim Conrad and Officer Don Stanko. They came and they talked about how you guys might sometimes make some poor choices online because you just kind of make choices fast, and how the internet gives you a false sense of security because you're like, oh, nothing bad can happen. I'm in my own house. They don't know. A lot of bad things can happen. So if you want to see it, it's posted on the PTSA website or it's just up on my YouTube channel. It was good talk, good information. Also busting out some of the apps that you guys might be using that your parents will now hopefully know about.
My mom doesn't even know what a phone is.
She's like, back in my day, we didn't even have cell phones. We had phone booths.
So, 10 minutes remaining. Olivia, what'd you do first here?
Okay, well, first I added 9 to both sides.
She added 9 to both sides. So you must have decided the right side will be your constant side then, right? Because you got rid of it on the left side.
I guess.
You guess. Because then we have 6x equals 4x plus 12. So I'm going to bring that over here.
Does it matter which side is the constant?
So I'll tell you, no it doesn't, but if you solved it right, you will have the same answer that we have. So assuming you solved it right, you'll have our same answer. Leah, what would we do next?
Subtract
Subtract what?
X.
Yeah, but how? So now my left side, I've decided, is my variable side. So I want to get this variable value with it. So we don't just subtract x, we subtract 4x. to get this to come over here and join up with my other variables.
That's what I did.
Then we'll have 2x equal to 12. Nate,
Then you just divide by 2 on both sides.
we divide by 2, cut it in half,
X equals 6.
and we get x is equal to 6.
Did it right.
Or you'll get 6 is equal to x, which is still saying the same thing. Now, with the got it, can anyone tell me how you think I might change this a little bit when I write it down? Karen? I mean, we could. That wouldn't really change anything. Nate?
You could flip the 2 numbers in the second expression.
So we like, instead of saying -8 plus 13, we'd rather say 13x minus 8, because that's a little easier for us to look at and us to solve, because we have a -8 constant value and a 13x variable value. So, and what Karen said was, I can take the second expression and write it first. Yeah, totally, because it's an equation. Order is kind of irrelevant. So then 12x plus 7. Ooh, I forgot my x. Grace, what would I do now? Many options. You actually have 4 options here that are all correct.
You would add 8 to both sides.
Sure, we could. Here's all my options. We could subtract 13x, we could add 8, we could subtract 12x, we could subtract 7. But whatever we do, we got to do it to both sides. So we add 8 like Grace told us. That then, my right side only has the variable now. My left side is 12x, or sorry, my right side now is 12x plus 15. Because 7 plus 8 is 15. What is, you still have a look of confusion. So,
Oh, hold on. I know what you
It's
said.
a different way.
that's fine. That there are 4 different ways to start. Oftentimes, you will not all solve it the same. So if your solution went a different route, that's fine, as long as you get the same answer that we get in the end. Ashton, what would you do next?
I'm not asking.
Rye, I haven't done that in a long time. Rye, what would you do next?
Do you subtract 12x?
Yeah, because I now have the constant by itself over here, I need to get rid of the variable. So you subtract the 12x from both sides. Conveniently, that leaves my left side as just 1x. So x is 15. Is that the same thing that you got, Zach?
Yes, it is. I got -1x. What?
Well, then you got -1x equals -15. So here's another route for solving. 13x minus 8 equals 12x plus 7.
And then I subtracted by the 7.
Yep, so you subtracted the 7, subtracted the 7. What that really gives you is 13x minus 15, right? Yeah, because -8 minus 7 should be minus 15. I think that might be where your mistake came in. Then that will equal 12x. Then we would have to subtract the 13x to get rid of the the variable value over there.
-1x is equivalent.
So -15 is equal to -x, which really, if I multiply both sides by -1, so I multiply here by -1, and I multiply here by -1 just to make them both positive, because I don't really like working with negatives. Or you can really just think of, if I wipe out a negative here, I wipe out a negative there, and that tells me 15 is equal to x, which is the same thing that we had. There are 2 other routes that we could take as well.
Please.
Not going to show those.
We'll see what next. Oh,
How
show
much
we
time
have
do we
left.
have?
Can I check? 3, 2, 1.
About a half hour. No, 4 minutes and 40 seconds.
About a half hour.
About 20 minutes. All right. Suppose the temperature in your town is 20 degrees Fahrenheit and rising 1.5 degrees each hour. Your friend lives far away, so sad, and the temperature is 28 degrees and falling 2 degrees every hour. Sometimes I do this with my sister because she lives in Maine. I'll call her and be like, hey, what's the weather there? Because it's, it's kind of far up. And if we get snow, then it travels up to them. So how would we write our temperature of 21 degrees rising 1.5 every hour? How would we write that, Ella?
I think a 21 plus 1.5 H.
Yeah, 21 plus 1.5 H. Actually, I'm probably going to have to move that down to here. Equal to, how would we write your friend's city temperature, 28 and falling 2 degrees every hour? Peyton?
28 minus 2.
Yep, 28 minus 2H. Now, when you start looking at an equation, notice the difference between how I solved it first and how we solved it to catch Zach up. I always suggest if you have a variable term being subtracted, we don't like negative values. So look for a variable term being subtracted and undo that. That's what I look for first, is how do I get my variables to be a positive value? Now, it won't always work. Sometimes you're just stuck with negative variable values, but a lot of times we can do the manipulation to get it positive. Shahid? Yeah, sad map. You're good. But that, yeah, it's exactly what we're doing. We're doing addition, subtraction first, and then we'll find out, is there multiplication, division to be done. So that equation becomes, I still have 21 on the right side, or left side. I'm using my right hand, that's why it's like I get switched around sometimes. This becomes 3.5H equal to just 28. Now, Ashton, your card was up. That's, I think, why my brain switched it up. What would you do?
Subtract 21.
Subtract 21 because I see I have my variable values together. I want to get it alone. Bless you. That gives me 3.5H equals 7. Zach? H is 2. When we do the division, H will then be 2. So, yeah, in 2 hours, our towns will have the same temperature, and then his town will keep falling probably, and my town will keep going up. So if we were to graph that, we're not to that point yet, but our town, or his town, starts higher, is dropping. Our town starts lower, is rising. Where they cross, that would be our 2 hour point. So we're not there yet, but that would, and then what would the temperature be then? If 2 hours have passed, his town dropped by 2 degrees each hour. My town rose by 1.5 each hour. 24 degrees. So the Y value here would be 24 degrees. So that is actually called a system of equations. It's a linear system of equations because they're not curved, they're straight lines. So that would be the solution to the system of equations, which we'll get to later in the year. Questions here? Try this on your own. Town's population is 14,000, increasing by 160 people every year. Nearby town, 24,000, decreasing by 200 people every year. How many years will it take for the populations to equal each other?
Seems kind of unrealistic.
Actually, not really. If you look at Michigan and some other places, as industry closes, as businesses like shut down and people don't have jobs, they leave. And as people leave the town, more stuff closes and more people leave. And it's really kind of sad when that happens. What would be my advice for a first step here, Mr. Boyer?
Add by 200Y.
Yep, add the 200y so we can get positive variable values. That then will give me 14,000 plus. And actually, guys, if you're really good at this, and especially if you use colors, you could do both steps at once. Because I've decided my left side is my variable side, so get rid of the constant. So these are the two steps that we'll take to get variables to the left, constants to the right. So that gives me then on the left-hand side 360y. On the right-hand side, it will give me 10,000. From there, to solve for y, we just, class, divide by 360. Does this all seem to make sense?
Yes.
Yes.
Whoever said no or used messing.
Yes. I see it now.
So then y would become, and
27.7.
so wait, the 7 repeats?
Yes.
How do we write a repeating 7 as a fraction, Shahib?
Oh,
As a fraction. Yeah, you gotta wait till the end of the sentence. Boyer?
7
7/9. Whatever repeats goes over 9, and that would be years. If it repeats 1 digit, there's 1 9. If it repeats 2 digits, there's 2 9s. 4 digits, 4 9s. Yes, but if you had a number that repeated 100 digits, that would be a pretty crazy number. You could make it happen. Like some of the most fun that I had in college when it was like challenge, can you do this?
Yes.
So one of those like, can you make a 100